This week our topics include Java packages, Java documentation, enumerations, and recursive method calls. So we begin with our presentation that is called Object-Oriented Programming Skills. Alright, so first topic is Java packages. Java packages we've seen multiple times that, for instance, all Java API classes that come with the Java standard library are organized in packages. So, for example, the number format that we discussed in our previous series is placed in the package name Java text. So packages, generally speaking, are subfolders. So this is the higher level and this is the next level, and then at a certain level we begin to place our classes, our Java source files. So packages organize classes into logical groupings for importing using import statements at the top of our source files. So the application may also organize our own classes. So it's advisable that we do not use a default package, but create a certain package in our root folder of Java source files. And of course, you will see that in NetBeans environment, when you organize your packages or create projects like this one, typically you will find a source. So this is the root directory for our source packages, and then we can have packages and sub-packages. So for example, if you're programming user interface tier, then you'd normally place all of the classes that handle user interface in a separate package dedicated to your user interface. Likewise, if you have a business model and you have a set of business objects that implement various business rules, you can create a business model package and place your classes in that specific package. And so forth it goes with databases and other needs, computational engines, and so forth. So the packages allow us to keep our source codes well organized. Now, the classes from nested packages cannot be accessed without being imported, and it's just a simple rule that we have to follow when constructing and organizing our source code. So the package names must match the path to the subdirectory where each package is stored. Essentially, these packages in the structure of our project is representation of the underlying folders. However, in embedded systems, there may not be necessarily a hierarchical file system structure which allows you to have directories and subdirectories. So it may not always be the case that the Java packages will correspond specifically to the file system objects such as directories and subdirectories. However, in most cases, this is the organization of the packages. And so this is our example of database connection, which is placed in a database package which in itself belongs to package name BCC, and at the source level we have the root package. So to be able to import something like this in other places, you just use the import statement that will refer to the location of this class DB connection in this Java file by using pretty much the same structure as this right here. However, this is a file path supposedly on Windows, and this is the import statement, a reference to that specific package and class within that package. Also, it should be noted that the very first statement in your source file has to be the package statement that explains to the compiler which package this class belongs to. And the import statements must follow the package, so they have to be right below the package statement and not anywhere else in this file. Now, it's not necessarily always the case that you're programming an application that has the main entry point, the main method, and therefore once you have the main method and it's callable from the outside of your program, and therefore it qualifies your class as the main class in your application. It may not necessarily always be the case. So sometimes you just want to create a library of classes that you can use elsewhere. So in that case, you probably would want to create a package or a system of structure of packages and be able to compile your code as a library. Okay, so in NetBeans, you can right-click on the project and select the build command and compile the project, and NetBeans will automatically create a jar file for the project that will include what you have there. So if we go here and say clean and build, for instance, already finished building, but I need to be able to see our output window. And in the output window, you can see that we do have created this jar file. So jar stands for Java Archive, and jar file can be runnable on systems that has Java virtual machine installed, so that it can be executed from within the Java virtual machine. Jar stands for Java Archive, and it's simply a file that has structure similar to a zip archive. But likewise, you can also place a set of classes in a package and create a jar file, and then be able to import that jar file in the libraries right here in your other projects, and be able to import classes from that jar archive, which will be representing your library. Right, so in NetBeans we can create or open project that will use the library, and if you want to add something there, you can go to libraries in the projects tree view and right click and say add jar, and you can specify the location of your jar file and include it as a library, and then reuse a set of classes at the jar level in your other projects. So the next set of topics is Javadoc comments. Now you can see that I left this Javadoc that was generated by the wizard. When I created this project, I specified that I would like to create the main class, and it generated this main class for me, including the main method. And it automatically created this what we call Javadoc. So Javadoc is basically the comment attached at the top of your methods, classes, variables, data attributes, pretty much anything that can be identified in your Java source file can be documented by Javadoc comments. Javadoc comments begin with / and 2 asterisks. So if I remove this portion from my code, and so now of course it looks like unfinished multi-line comment, and so if you type something like this and just hit enter, you see how it regenerates automatically Javadoc. So we can practice a little bit with this. Let me create a method such as void method 1, and I'll use method that has no parameters and does nothing. Then I'll add a void method 2 that will take a string. Okay, string str as a parameter, and also just keep it for the purpose of demonstration. So if I would like to provide documentation for these methods, I can make them public so that they're usable outside of this class. And if I now would like to document my code, I can basically use a / add to asterisk and hit enter, and see how it adds this Javadoc. So at the top of the Javadoc, I can explain that this method demonstrates Javadoc format. Okay, so something like this. This would be the documentation for this method, so it explains what this method does. Likewise, if I hit / asterisk right here and hit enter, you see how it includes this parameter right here. So I can basically duplicate what I did over there, and I can say that parameter string is an input parameter, right? So we can add another method, for instance, call that method something like sort array. Okay, and here we will pass an integer array. I call it array like this. So once again, to generate Javadoc, hit this. So here we can again say that this method will sort the elements of the array of integers, and array is a reference to an array of integers. Okay, so it's not really that difficult to keep Javadoc comments in sync with your coding, and of course if parameters change, you would have to update your Javadoc comments and keep them up to date. And the benefit of using Javadoc is that we can click run and generate Javadoc, which is an HTML based documentation for our source code. So let's try this. I'll say generate Javadoc, and you see that it creates a local HTML combination of HTML files that looks pretty much like standard documentation. So here's my main app, and you can see that my Javadoc is basically includes everything that I was using in my code right here, and I can jump around these methods, and I can navigate this pretty well using the standard organization of the Javadoc. So there's a package level, right? There is a class level that we can examine right here, and that's the whole idea behind Javadoc, so that we have a well-organized and standard way of documenting our applications, and basically write both code and documentation and keep the documentation up to date. So the possibilities with Javadoc are pretty simple tags. When we have parameters to our methods like this and like this, you can see that we're using @param tag, then specify the name of the parameter, and then we can write what this is. So this is input, or we can say command line arguments. Right, so this is an array of command line arguments if our program was run from the command line. And so we're going to get this array of strings that correspond to the command line arguments. And just like this, I can keep adding my documentation right here. This could say main method, and this describes at the top basically a brief description of the entire method, and here I can specify some details, right? Details, so I'll just use this details, and duplicate it many times like this. And if we regenerate our Javadoc, the website gets updated. So this time you can see that if we go to our main method, so now all of these details are added right after the parameter description here, right? And if I wanted to document the entire method, then these details would go up to the top like this, right? So these would be the details about the entire method. And you can include your own HTML tags in this documentation, and so that's pretty convenient and nice to have, as basically every Java integrated development environments like Apache, NetBeans, Eclipse, and others would have features to support your Javadoc. In addition to this, you can go to Tools and say Analyze Javadoc. It would then open essentially a similar tree structure that you have here, and you can click around here to make selections, and as you run the analyzer, it will actually also generate Javadocs for missing comments for Javadoc documentation. In addition to this, you can also go to Tools, Options, and under Options, and it's under the editor, you can also turn Javadoc on and off and tell the environment, basically control NetBeans environment, whether you want to be able to create Javadoc, and whether you want to report errors, like we see errors sometimes. So for instance, if I say integer xyz equals ABC, so typically this is reported as an error, right? So the source editor already analyzes the structure of this program and already reports that there is some kind of strange thing happening here because ABC is unknown identifier. So if Javadoc is missing, not here, you could turn it on as an error, and it can be highlighted when you analyze Javadoc. So these are the basic features, very useful features that, of course, are pretty standard, and that's the idea of Javadoc. So you can provide at the top, so we can also document, for instance, we can document what this package is, right? So we can explain what this package is. So this is a package for demo of Javadocs. We can do this. We can provide a version, right? So we can type what is the version, and we can say that this is version 1.0 and so forth, and explain that this is alpha version, something like this. We can of course document parameters, as we did in our Javadocs for our methods right here, and we can also specify what the methods return. So if I change this specific method to return an integer right here, this is an integer, and I'll say return 0. Okay, and so if we regenerate the Javadoc right here, right, so we can type this, and I'll just add a return Okay, and we can say that the method returns 0 if everything is okay, something like this. So we save this, and once again we go to run, and it's under the run menu that we can regenerate Javadoc for our application. And we go here, you can see that now we have more documentation. As we move to method, this was method 2 that now has the return documentation, and right here it explains what this method returns. So everything becomes pretty standard, and of course you can write much more extensive information in those Javadocs, but generally a very useful set of facilities.